Hello everyone. In today's section, we are going to see about directional control valve. And myself, Sanjay Sarvesh, and my teammates are Gokul Sundar, Akshay, Deepak, and Suman. We are all going to speak about directional control valve. So, coming to the today's session, we are going to be having a look at on directional control valve. Will be the part of one or two directional control valve. Viva basic with the looking for a 4-part of directional control valve that feature a blocked P port when the center or a neutral position 4 port directional control valve typically have the 4 labels P, T, A and B. The P port is for supply chain from one pump, T port for the return to the tank reservation, and the A and B port are typically known as the work ports and are connected to the cylinder. Let's get started with the 4-port 2-position valve that does not have a center position. So on the symbol you see P to the port to extend the cylinder and P to B porting to react the cylinder on the actual valve. So you can see in the video that you will be a cylinder spool sliding inside the cylinder valve bar. The spool has a large diameter area called lands and smaller diameter areas called undercuts. This valve with its 4 ports and 2 position is popular enough to extend and react a cylinder but does not allow the user to stop the cylinder. So in mid-stroke, the spring will be inside the particular valve, return, and the valve will spool to the P to the position where the lever is released. So notice that the reflex valve will be taking the care of limiting maximum system pressure whenever the cylinder is death-headed against the fully extended or a fully reacted position. So in the video you can see that the changes of the 4 ports, port B position valve in the symbol, you can see that the center position has been changed, added along with the second spring to the spring in the symbol, means that the valve is spring center. Notice that P port is blocked when it is center position. So the relief valve is limiting system pressure. The B and the T ports are also blocked, making this a closed center valve. And the mechanism of the valve spool shows that the lands are blocking and the A and B ports, the P port are coming into the undercuts on the spool, but flow cannot move in the other port. So therefore the P port is blocked. You can see in the video. So the port is available on the both side of the animation valve, but again is not connected to any other port at that time. You can see in the animation. So activating the valve shows us that we can provide P to the flow to extended to the cylinder, or port B and B flow react to the cylinder releasing handle shows we can find in the fact of stop the cylinder in mid-stroke. This is the common feature and is decided in many hydraulic system. It is especially popular for horizontal cylinder installation, but we can as soon find out there is no greater vertical installation in the animation. So the valve seems to perform just fine, but can you imagine what's happened? The cylindrical valve spool move when the for many thousands of times through the same valve broken. That's right.
Here I am continue to retract the cylinder releasing the handle, show that we can in fact stop to cylinder mid-stroke in this common feature and is decided for many hydraulic systems. It is especially popular for horizontal cylinder and installations, but as we will know soon as not great for vertical installation in this animation. The valve seems to perform just fine, but can you imagine what happens as the cylindrical valve spool moves back and forth many thousand times of through same valve bore? That's right where will start to occur an internal valve leakage will develop, and we will find out the cylinder is slowly drifting and downward whenever the valve handle is neutral. Now let's look at the valve that typically referred to as a float center valve. Just as before, the P port is blocked at the center position, and however the A and B ports are now connected together. Notice that the lands on spool have been machined back, allow the B ports and A port to connect the tank during the center position. If you are watching this cylinder, you will notice that it fell all the way to bottom.
From here on, all the way to bottom the float center literally leaves the cylinder floating freely. Believe it or not, this valve center is quietly popular for the vertical cylinder applications. Needed to add the pilot operating check valves in order to hold the cylinders mid stroke. The small diameter pilot lines are not continuously flow lines. They are merely provided a tiny fixed amount of fluids and the pressure needed to operate the pilot piston. When the pilot piston is extended, it allows reverse flow through the check valves. Ball and the seat side are popped, and the seat side check valves are usually considered a much more reliable leak-free valves, as the main components of such a valve do not wear against each other. The float center valves in this case is most desirable to make sure that the pilot lines are completely went to the tank to allow the springs.
Here I will continuing. Completely when to tank allow the spring inside the check values to close. The check values completely hold the cylinder mid stroke in the both of the 4-port 3-position directional control valves that we studied. The closed center and the float center of the B port was blocked. The use of these values is typical to what is referred to as a closed center hydraulic system. In many cases, our gear pump would be replaced by a pressure compensable variable pump in order to avoid excess pumping over the relief valve. In another video, we will cover the tandem center valve and the open center directional control valve. That's all for this time. Thanks for watching. We have hundreds of interactive resources like this video schematic, so you can try out the wild ideas without blowing anything up.
Previously, they have mentioned about the principles, definitions of directional control valve. Now I will explain about the advantages, disadvantages and applications of directional control valve. The advantages are the directions can be controlled easily, such as the forward movement and reverse movement of the hydraulic cylinders, and it is a simple operations which can be easily understandable. The response is very fast, the design is very compact, automation is easily possible, and it provides high efficiency, and there are multiple configurations available. The disadvantages, however, are there may be leakage, maintenance is required for this. The advanced types are very costly, and you cannot provide a cost-effective solution for this. Pressure loss, sensitive to containments. Applications of DCV: hydraulic press machines, industrial automation systems, excavators and construction equipments, material handling equipments, injection molding machines, pneumatic system, machine tools, etc.
Frank Banks.